Welcome to the Chapter 4 lesson video. We're going to talk about radical equations today. Let's go ahead and get started. If you don't have any notebook out or anything like that, you should take something out so that way you can take good notes and pay attention a little bit better as we go through this. All right, so solving radical equations and inequalities. We're going to focus more on the equations part this semester and this time around. We'll see mostly that as we're doing these examples here. Okay, so first things first, let's go ahead and read through the steps here. We can solve radical equations involving radicals by using powers equal to the radical's index. So like to get rid of a square root, we use a square, cube root, we use a cube, and so on. We always have to double check our answers for invalid solutions. Okay, remember even indexes must always equal a positive number. That's something we've talked about a little bit earlier. But let's go and look through the steps. First of all, we want to isolate the radical to one side of the equation if possible. That's usually something we can do. We're then going to raise each side of the equation to a power that matches the index. This is usually pretty easy. Sometimes there's a little bit of trickiness involved where you might have to FOIL or distribute. And then lastly, we're going to solve algebraically. This is your basic solving for x stuff. And then we check for invalid solutions. Basically, you're going to check to see if you were to plug your answer back into the x's, wherever they are in the problem, does it ever make an even indexed radical equal to a negative? Because if not, if it does make it equal to a negative, we got to cross it off. If it always equals something positive, then we're good to go. We'll see an example of that as we go. So let's go ahead and do this first one. This first one is pretty straightforward. We'll go ahead and dive right in. First of all, I want to isolate the radicals. To do that, I'm going to add 5 to both sides. Add 5 to both sides. Okay, that'll give me 6 equals the square root of 2x. All right, and so to get rid of the square root, what I'm going to do is I'm going to square both sides. So a square will undo a square root, so we'll square both sides. I wrote that on the wrong side of the 6, but that's okay. So the square root of 2x squared is going to be just the 2x, and 6 squared is 36. All right, now we just need to solve for x. So we squared both sides. We have 2x equals 36 left. We'll divide by 2, and we will get x equals 18 as our final answer. All right, we can box that answer, but we should absolutely double check. Make sure if I plug 18 in, no, it's not going to affect, it's not going to make it equal anything negative as a whole. Let's keep going. All right, so here's another example, a similar idea. We're going to try and get the radical alone, move everything to one side except for the radical square, since it's a square root, both sides, and see what happens. So let's go ahead and start with that. So I'm going to start by subtracting the 20 over. So 6 minus 20, that's going to be negative 14 equals 7 times the square root of x plus 1. I'll then divide both sides by 7, so I'll get negative 2 equals the square root of x plus 1. I can then undo the square root by squaring both sides. So I'll square and I'll square. Be careful here. Make sure you square the negative 2. So you square the whole thing. Notice how I put parentheses there. And so that's going to become a positive 4 equal to the square root of x plus 1 squared is x plus 1. Subtract the 1 over and you get x equals 3. All right, double check, make sure it doesn't cause any issues. 3 plus 1 is 4, that'll be fine. Nowhere else to plug in, you're good to go. All right, so we got some more examples. We'll do some more examples here. We just kind of similar to what we were doing, and we'll see what happens. These ones shouldn't be too hard. All right, so on the first one on the left here, the radical is already isolated. The only difference here is it's a cube root rather than a square root. So we will cube both sides. Cube both sides, that'll leave us with x left on the left. And then negative 5 times negative 5 times negative 5 is negative 125. And that is okay here. It's okay for an odd indexed radical to equal a negative, just not evens. All right, let's keep going along. On the next one, the radicals are both isolated. So this is kind of a unique situation where we have two radicals that are equally isolated. We can get rid of both radicals at the same time by squaring both sides. So I'll square here, I'll square here, and it'll just leave me with what's on the inside. 2x minus 5 has to equal 3x. I will subtract the 2x over, and I'll get negative 5 equals x. And that is okay. Now it's okay in this instance for us to have an x that's negative that plugs in That's okay. That's not an issue here. We just can't have the whole radical equal a negative number on the outside. So you just can't have something, for example, like the square root of x plus 2 equals negative 5. That's not allowed. You can't have a square root equal to a negative. All right, so this one's a little bit different. This one's a little bit trickier. The radical is isolated, okay? So we're going to square both sides. But since I have this x plus 3 on this side, I can't just square the x. I can't just square the 3. I have to square the whole thing, which I know is a struggle, and some people forget this, but this means x plus 3 times x plus 3. You have to distribute that out. Okay, so when you multiply this, you're going to distribute it out. So you will get x plus 5 on the left, x plus 5 on the left, equals x plus 3 times x plus 3. We'll distribute that out. You'll get x squared plus 6x plus 9. And you'll notice we have an x squared, which means this is a quadratic. So we're going to move everything to one side and try and factor. So we'll get 0 equals x squared plus 5x. 9 minus 5 is 4, so plus 4. And then we're going to try and use a factoring method. That's usually our best hope for these. You could use quadratic formula, but that's usually a little harder. Multiplies to 4, adds to 5 is 4 and 1. So we get 0 equals x plus 4 times x plus 1. Awesome. Those are my two factors. Now I got to ask myself, what can I plug in to make these equal 0? Okay, so let's see. What can I plug in to make them equal 0? I can plug in an x have a negative 4, and I can have a negative 1. Now this is where we check our answers, and this is the important time. Okay, so we check our answers. We say we have this square root over here. I want to make sure that if I add 3 to either of these, it doesn't make a negative. So let's see, negative 4 plus 3, negative 1. So negative 4 is an invalid answer because when I plug that negative 4 in, I would get the square root of negative 4 plus 5 equals negative 1. And you cannot equal a negative. That is not allowed. All right, let's check the other one. Negative 1 plus 3 is positive 2. That is okay. So our actual final answer is just x equals negative 1. That is our only real answer here. All right, with that, that's all we have for the video. If you have any questions, please reach out to me. Otherwise, I'll see you in pause or I'll see you in our next live session. And until then, I hope you have a great day.